And now for the last page. For 76 and 77, determine whether each relation is a function. This is Unit 3, Lesson 2. Okay, this one right here is a function. It passes the vertical line test, which means if I pick any vertical line on this grid, it's only going to cross the function once. If it crosses more than once, it's not a function. Every single function passes the vertical line test. So the fact that it passes the vertical line test makes it a function. Okay, 77 is also a function. The domain does not repeat. What repeats here is the range, right? So the -1 got repeated. 8 goes to -1 and 10 goes to -1. But nothing got repeated in the domain, so it is a function. Okay. 78 is a Unit 5 problem, because I see that I need a system here. Spencer bought 5 tacos and 2 burritos and spent $8.13. Stacy bought 1 taco and 3 burritos and spent $5.76. How much was 1 taco? Okay, so we want that answer, but to find that answer, we might have to find the price of a burrito. So I'm going to say T is the price of a taco, and B is price of burrito. So we want to write an equation for Spencer, which is hopefully pretty easy. 5T plus 2C, or sorry, B, not C, equals $8.13. Then we're going to write an equation for Stacy. Stacy bought 1 taco and 3 burritos and spent $5.76. We want the price of a taco. There's 2 ways of doing this. One, you could eliminate the B. If you eliminate B, you're going to find the price of a taco immediately. Or you could find the price of a burrito and then use that to find the price of a taco. Okay? So I'm going to go ahead and do it the first way. I'm going to eliminate B. To do that, I have to multiply this one by, I'll go by 3, and I'll multiply this one by -2. So that's 15T plus 6B equals 813. I think it's 2439, but I'll do it on the calculator just to make sure. Ignore this announcement.
Nathan Hauser, please report to French Club. Nathan Hauser, please report to French Club.
It's 2439. Okay. -2 times T is -2T. -2 times 3B is -6B. And 576 times -2 is -1152. Add these up. 15T plus -2T is 13T. 2439 plus -1152 is 1287. Divide by 13. And I get my taco, T is 0.99. And that's all we needed, because I just asked for the price of a taco. I've got it. I don't need the price of a burrito. Hopefully you realize that if I wanted to find the price of a burrito, I could easily plug that back in and get it. Don't need to here, though. Okay, 79. Alex is collecting Beanie Babies. He started with 7 and adds 4 per week to his collection. April is trying to get rid of them. She has 176 Beanie Babies, but she is selling 9 per week. After how many weeks will Alex and April have the same number of Beanie Babies? How many will they each have at that time? So this is asking 2 different questions, which means there's 2 different variables. Okay, so we're going to look at Alex and how many total Beanie Babies he has. So we'll say T is total Beanie Babies, and I'll say BB for short. And the other thing that we don't know is after how many weeks. So W is number of weeks. By the way, this is a Unit 5 problem as well, because it's a system of equations. I could see where you could throw it in as Unit 1, but I'm going to go with Unit 5 here. So let's write an equation for Alex. His total Beanie Baby count, he starts with 7, and he adds 4 per week. Okay, so that's Alex. April, her total Beanie Baby count is 176, but she's selling them at 9 per week. So she's subtracting 9 per week from her collection. Now we just want to know when they're the same. So I'm just basically going to use substitution. Plug that in, and we get 176 minus 9W equals 7 plus 4W. I'm going to get my W's together. So 176 equals 7 plus 13W. So it's 169 equals 13W. Divide by 13. I get the number of weeks is 13. How many do they each have at that time? Well, put 13 in for W. 4 times 13, I believe, is 52. Plus 7 is 59. And if you just want to make sure, you could easily check it with April. So 176 minus 9 times 13 also gives me 59, so I did it correctly. Okay, last 4 problems of our review. For 80 through 83, use the following situation. After 8 hours of working on the farm, Adam has $339 saved in his bank account. After 14 hours, he has $409.50 saved in his bank account. Okay, write an equation to represent this situation. As soon as I say write an equation, I'm meaning linear equation. I'm talking about unit 4 here. So what I've given you is 2 points, where x is the number of hours and y is his total in the bank account. Okay, so after 8 hours, he has $339. And after 14 hours, he has $409.50. We want to find the slope. Okay, so I'm going to subtract the 2 y's. So 409.50 minus 339 divided by the x's subtracted. So 14 minus 8. So 409.50 minus 339 is $70.50 divided by 6. It's $11.75. That's the slope. Okay, so he makes $11.75 per hour. Okay, so that equals my slope. Now I need to find the y-intercept. So I'm going to use this point here. It doesn't matter. You could have used this one, but this one doesn't have a decimal. So I'm going to use the 339, put it into y equals mx plus b. Slope is 11.75, 8 hours, and 339. And what we're doing is we're figuring out how much he had at the beginning. Okay? So plus b. So he made, after 8 hours, he made $11.75 per hour. He made $94 in that amount of time. And then if you subtract what he has in his bank minus what he made, you'll get what he started with. And b is 245. So my equation is y equals 1175x plus 245. And now the next couple questions are asking you to interpret your equation. I kind of already talked about it, but we're going to talk about it again. What is the slope? 1175. What does it mean? It's his amount made per hour. It's like a rate of change. Slope and rate of change mean the same thing, but rate of change has a meaning to it, so that's what it means. How much did Adam have in his bank before he started working on the farm? That was $245, right? That was the y-intercept. And how many full hours will Adam have to work to make $1,000? So if this is his equation, I'm going to take 1,000 and I'm going to put that in for the total money. So I put it in for y. So $1,000 equals 1175x plus 245. And I have to solve that for x. So I'm going to subtract 245. So that's how much he already had. So 1,000 minus 245 gives me $755. That's how much he needs to make working. Divide by 1175, and I get x equals 64.255 ... There's not a perfect number. We've got to round it. How many full hours will he have to work to make 1,000? Well, if I take that down to 64, he's not quite at $1,000. Don't believe me? Let's try it. Do 1175 times 64 plus 245. It's only $997. It's not quite. So I have to round it up to 65 hours. Okay? And that is the end of page 11 and the end of our review.